Hello class, we are going to lecture 24, Interpreting Confidence. I'm your instructor, Ms. Laura Lowe. In today's lecture, the first thing we will review the bootstrap we talked about from the previous lecture. Then we'll give you more example about the confidence interval we use for the bootstrap. So we need to understand how the confidence interval mean and also how you interpret that. So we have a couple discussion questions for you. So then at the end, we will see the example about how to use the confidence interval for the hypothesis testing. The first thing, let's do a quick review from the previous lecture. From the previous lecture, we talked about estimation. Why we need to do the estimation? Because we want to estimate the parameter that will be a fixed quantity in the population. We may not be able to get that directly because the time and the limited time and money. So that's why we want to get the parameter from the population. We may not be able to get that. But one thing we can do is we can get our samples, random sample from our population, then we estimate the parameter. So that's how we figure out the value of an unknown parameter. When we couldn't get that population, so that's how we get a random sample from the population. Then we use a statistic as an estimate of that parameter. But one sample, one statistic, one estimation. So the random sample could be come out differently from the parameter. But how do we know? So the estimate could be differently from how you do the random sample. So instead of we get one estimate, only one number to interpret the parameter from the population. So maybe we can get more sample, then we get a range to interpret the parameter or to estimate the parameter. In order to get more sample, it's difficult to go back to the population to get more sample data. Instead, we have our technique we introduced, that's the bootstrap. So the bootstrap actually is not creating the new sample from the population. Instead, we're using our original sample. We just do the resampling from that original sample. So that's how the bootstrap works, right? So we have our population. Because the limited time and budget, we only can get one original sample. But using the bootstrap technique, we can create multiple resample. So those resample will be the same size from the original, same size for the original sample. We all draw from random, but with replacement. So then we can create multiple resample. All those resample and the original sample, the distribution will look pretty similar and most likely. That's why we can using the all resample data, then we can come up the empirical distribution and giving an interval, confidence interval for the parameter in the population. Few things we need to keep in mind when we applied the bootstrap technique. The first thing, of course, our original sample need to be large enough by random and to interpret the population. Then when we're using that original sample to create the resample, we will draw at random with replacement. So that's why we will have the same number of sample size from the resample as the original sample. The size of the new sample, or we say the resample, has to be the same as the original one. So that's why all our estimates can be comparable. That's how we can draw our empirical distribution. Let's see our example from the previous lecture about the San Francisco worker information. So then we have our San Francisco city worker, their total compensation. Of course, from this population, we can find our median. So then we get the population median is 135 something. But remember, one thing is, in real life, we don't have the population data. But the purpose here, we have that just want to see how well our bootstrap technique can work. So then we already done the bootstrap process from the previous lecture. But here, that's being more organized to write that in one function. So here we will have our confidence level is 95. And according to different sample size. For our previous example, we're using 400. But later we will also show you on how the sample size will affect. And also remember, at the end of last lecture, we also show you on the difference between 100, how the sample data, the original sample data will affect your result for your confidence interval. Okay, so then I ask you to do more practice from the demo lecture file. But here, then we just do the confidence interval level is 95. Then we have the passing parameter is the sample size. So then remember our sample here is our original sample. So we get that from the population. Then you calculate the median. So then in order to do our bootstrap, so this one we do 1,000 times to do the resample. So then of course you will have the result in the bootstrap median array. So then we repeat 1,000 times. So remember, every 1,000 times you resample that, then you get your median. And so again, this function is the find the median value. But here, remember, we just resample again from our original sample because we want to get exactly the same sample size and with replacement. So nothing we need to pass from here. So after you get that, perform 1,000 times the resample. So then we have the result in the array. So we can plug that, but also we can just use this one to find our 95% confidence interval. Remember, this confidence interval, we assume they are symmetrically. So that's why you have the 5% shared by the left tail and the right tail. So we can using the percentile function to find out the left boundary and the right boundary. Okay, so then after that, you get your left and the right. So we just need to call this function again by passing your sample size. Then we can get the interval. Okay, so here just focus on this one. Okay, so this one actually we just using the sample size is 100. So then you will see here they have the range is 109,000 to 147,000. Of course, you can run many times. Also remember, because every time you get the new original sample, so that's why your interval will also be different. But I want you to pay attention from the number here, because this one is size 100. Okay, so then you can see they have actually a larger range from the sample size 400. Okay, so you just pay attention. So here we have the less than 130, but then up to 158,000. Okay, so you can run again. Okay, so then you can see, yeah, so 120 to 157. So that's the size 100, right? So we can change the size, sample size to 400. Okay, so then you can see they are higher 120 and to 140. Of course, you can run manually again and again to compare the range. But then you can see, right, so generally we can see the sample size 400 have a smaller range than the size 100. But instead of just manually to run that, so here I want to show you. The other one is here actually that's do 20 times for each sample size. So I have sample size 100 and 400. Then we do 20 times for each one. So again, each one actually we still calling this confidence interval 95 function. We pass in the sample size. So then since we repeat 20 times, so then we will have 20 interval range from each sample. Okay, so then you see here we run. So then you will see here actually they still running because we have each sample size 20 times. But remember each sample size when we do the 95% confidence interval bootstrap, we simulate, we resample. This one is not simulate. Yeah, we resample 1,000 times. So that's why you see they take a little while to finish that. So of course, let me post a video so we don't need to wait together here. Definitely make sure you also run this one on your side. Yeah, it takes a while to run. Since I paused the video, you don't see that, but actually it's about a minute. So that's why you can see here, because we run each sample size, we do 100 20 times. So then we do 400 20 times. But here, since we only show 4, yeah, I really want to show you. I should have beginning to show everything. But one thing is, if I change again, we need to take a couple minutes to run again. But one thing is, you can see the range about 100 is kind of really wider than 400 we have before. But that's okay. You don't see the whole table. That's plot that's in the scatter. We put it in the scatter drawing. So that's here. So what we draw here is we using our population median. Okay, so that's we call that true. That's we already calculated earlier. It's about 135 something. Okay, so then according to all the interval, yeah, see the lower and upper interval just mean the 95% confidence interval for each time we try. Okay, each time we resample. So then we draw that. So after you draw that, you can see here, this green line is our population median. So then we have the sample size 100 is the kind of black. Okay, so then here, oh, that's the blue. So that's why the sample size 100 is the bottom 20. So then sample size 400 is the up 20. So then you can see here when we have the red line just mean the population interval, the population median is not within our interval. But you can see this one even is not. They are still the lower bound very close by, right? And also you can see this one actually, this one is came from the sample size 100. The same, they are not really, yeah, because in the graph we will see, oh, maybe they touch, but they are not. So that's why we have the conditional operator here. If the population median is smaller than the lower bound or greater than the upper bound, we make the color red. Okay, so then you can see here, so in the 20 times resample, then for the size 400, we have 2, they are out of bound. So then the same thing for the size 100. But one thing is, I want you to pause the video, then to observe this picture. So then you can see this one actually, I want to visualize that is show you, because earlier we say the sample size 400 have a little narrow range compared to our sample size 100. So remember, we got our confidence interval to estimate the parameter in the population. But then one thing is, even we have the interval, right? But it's better we have a narrow interval, so then we can have better idea where the population parameter located. So that's here we show you actually your sample size, larger sample size actually help us more to narrow down the estimation. Okay, so we will continue in the next video to talk about more about the confidence interval.